Now, as you progress in your career in IT, you're going to notice that we love standards. We standardize everything. And there's possibly no more prolific standard in hardware and software than x86 and x64. Now, what we're talking about here when we mention x86 and x64 is essentially the amount of data that the CPU can handle at any one time, whether it be x86 and 32-bit or x64 and 64-bit. Let's take a look at that using our animation from before so that we can further understand this. So let's go ahead and bring our friend back in, the box. And we'll go ahead and let our friend the box talk to his RAM stick. So we have our CPU back here and we have our RAM here. And if you remember before, we had with our single core processor just a very thin lane of information that was able to go back and forth between our two components. We would technically refer to this very thin lane as a 32-bit lane, right? This actual system can only handle 32-bit chunks of information at any one time. Now, if we were to make this 64-bit, well, quite simply, you can see that our lane here has actually doubled. We have doubled the amount of space, so instead of doing 2 to the 32nd power, we're actually doing 2 to the 64th power. Let's take a look at that math on screen so that we can understand it a little better. So now that we have a better understanding of what it actually is, let's display this by doing some of the math. So we know that all computing standards operate in powers of 2, and we know that we have a 32-bit system here, so let's go ahead and calculate the actual amount of data or RAM that it can process. And if we take our 2 and go to the 32nd power, we can see that it's right about 4 billion total bits of information it can handle at once. Now let's do the same thing, but with 64-bit. Wowzers, that is a big difference. In fact, I promise you that if you do the math, you will figure out that a 64-bit system can handle 4 billion times the amount of data as a single 32-bit system. That is really exponential power. Now that we understand that math a little better, and it's pretty amazing that a single x64 or 64-bit CPU can handle almost 4 billion times the amount of data that a 32-bit CPU can handle. But now that we have a good understanding on that, let's extrapolate this a little more. So we have x86, which is our 32-bit instruction set architecture. We have x86 x64, which is our 32-bit supported but 64-bit primary software or hardware. And then we have our x64, which is only compatible with 64-bit. There's one more thing you're going to notice on the exam, and that is an acronym known as IA32. And that actually stands for Intel Architecture 32-bit, and it's just Intel's way of doing things slightly a little different. But if you see IA32 on the exam, just know they're referring to an x86-based system. Now, you might be wondering, well, what's the difference between 32-bit and 64-bit, right? Why would I want to? Well, almost all modern hardware and software now comes out of the package as 64-bit. They do support 32-bit counterparts of their same systems or hardware or software. However, 64-bit is preferred because you get far better security with 64-bit, far better graphics performance with 64-bit, and truth be told, far better system output in total with 64-bit. You might also notice that when we talk about the acronyms involved with this, you're going to notice x86-x64 and x64 used interchangeably. Just note that they actually refer to the same thing. And one final thing you need to know about 32-bit and 64-bit systems is that almost all modern PCs and applications are now 64-bit. You're going to have a really hard time finding old 32-bit hardware or software being produced today.